Alright, welcome back guys. So we're going to start looking at some unit conversions. Okay, we had talked about these in the last video, but if you look right here, all a unit conversion is just a statement of equality essentially. It's just, it says 12 inches is equal to 1 foot, or 24 hours is equal to 1 day. Okay, so whatever it is that you're measuring, both of those measurements represent the same quantity. There's all kinds of them. It could be, 4 quarts equals 1 gallon. Okay, it could be, I don't know, 4. Well, no, let me not do that. It could be 100 cents equals $1. Okay, so these are just different units of measurement, but they represent the same quantity. Now we're going to use these as fractions. You're going to put one measurement in the numerator and then the other measurement in the denominator. Now, to know how you orient it, which unit you put in the numerator versus which in the denominator, that depends on what unit are you trying to cancel or eliminate, and what unit are you at which you're trying to arrive. Okay, so if I'm looking to convert miles to kilometers, then I need to cancel or divide out my unit's miles so that I'm left with kilometers. Okay, and I'm going to show you how to do that. Now, of course, in my face-to-face classes, I would ask the students, what other conversion factors can you think of? So, it could be 60 seconds is equal to 1 minute, or that 1 kilogram is equal to roughly 2.2 pounds, things of that nature. Okay. All right. And know this too, guys, there are different measurement systems, okay, around the world. So, alright, so this example 5 here, it says convert a length of 102 inches to feet. Well, we're working with inches and feet, so we're probably going to use one of these two, either of these conversion factors. Now, which one I use depends on what unit I'm looking to cancel. Alright, so the way you're going to set these up is you're going to start out with what you're given. You've got 102 inches. You're going to make that a fraction by putting it over 1. And then you're going to multiply it by your conversion factor. Okay. Now we know that 12 inches is equal to 1 foot. So we want to eliminate inches and we want to arrive at the unit feet. So the way I'm going to orient this is I'm going to put 1 foot in the numerator and then 12 inches in the denominator, instead of the other way around. Now, why did I do it this way? Well, because I have 1 unit, inches, up here in the numerator, and I've got that same unit here in the denominator. So we can divide those units out. Or in other words, you could say we can cancel them out. Okay, so my inches are going to divide out, and I'm just going to be left with the unit feet. Okay, so I can go ahead and carry over that new unit, which is feet. Now, as far as the arithmetic goes, we're multiplying two fractions again. So we're going to multiply straight across. So 102 times 1 is 102. But we still have something in the denominator here. We've got 1 times 12, which is 12. Okay? So in an instance like this, guys, you're probably going to need to go ahead and divide these out. So let's do that. And in your homework, it'll tell you to what decimal place or to what place value to round. So 102 divided by 12, that gives us 8.5, which is 8.5. So this is going to become 8.5 feet. Okay. All right, well, let's try another one. This little graphic right here, this just shows, these are two different, some people, if you're measuring something that's really large, like a running distance, you could measure it with a larger unit, like a yardstick, see? And a yardstick could be divided into, or subdivided into feet. There, it takes exactly 3 feet to make a yard. So, anyway. All right, what about example 6 here? How many seconds are there in one day? Okay. Well, what we're going to start with is what we're given. One day. In other words, what we're trying to do here, guys, is we're trying to convert one day, which is a length of time, into seconds, which is another unit of time, except a second is a lot smaller in length of time than a day is, okay? Just like a day is a lot shorter than a year. All right, but in any case, I'm going to start out with one day. So in this case, my unit is day. It's a measurement of time. Times, now I'm going to use a conversion factor here because I need to go from a very large unit of measure to a very small unit of measure. And it's difficult to do that directly. So I'm going to go in steps. I'm going to try to convert a day into the next smallest unit of measure, which would be an hour. And I know that there are 24 hours in one day. You can even write this up here. 24 hours equals one day. Okay. So this is a conversion factor. Now how I orient it depends on what unit I'm looking to cancel. Well, I want the days to cancel. So since I already have a unit of day on top, I'm going to put the one day in the denominator and the 24 hours in the numerator. And so if I could go ahead and divide out those days. So now I'm left with the unit hours. So now I need to use another conversion factor. The next smallest would be, or the next smallest unit would go from an hour to a minute. And I know that there are 60 minutes in 1 hour. Okay? And I want to put the 1 hour in the denominator because I want my hours to cancel and I want to be left with minutes. So see here, we're gradually going from a larger to a smaller to a next smaller unit. So now my hours are going to divide out. And so I'm left with minutes, and so I need one last conversion factor to take me from minutes to seconds. And we know that there are 60 seconds in 1 minute. Okay. So again, I'm going to put the 1 minute in the denominator because I want those minutes to divide out and the 60 seconds in the numerator. So you can see sometimes this will require a string of conversion factors to do this. Alright, so I've finally made it to the desired unit, which is seconds. But now I need to work with all these fractions. Well, we are multiplying again. All we're going to have on bottom is 1. Okay, so I'm not going to worry about that. I do, however, need to multiply all these numerators. So I've got 1 times 24 times 60 times 60. So 24 times, couldn't I just write it as 60 squared? Isn't that the same as 60 times 60? And I get 86,400. And the unit now is seconds. Okay? These, guys, you'll use different units in many different situations. Like if you're measuring the length of a piece of furniture, you might use a ruler. Or, a small box, a jewelry box, for example, you might use a ruler to measure it in inches. But if you're measuring the length of a piece of furniture, You could use inches to measure it, but it's going to take a lot of inches. So you might want to go up to the next largest unit, which would be a foot. You can measure it in feet. But if you're measuring the distance, say, of a football field, then you might, instead of using a foot, you might use a yardstick or a meter. Okay, and then if you're measuring the distance between school and home, you might want to use a larger unit, like a mile or a kilometer. You could technically still measure that distance using an inch, but it's, you're going to get a lot of inches there. So we typically use the unit that's most appropriate for whatever it is that we're trying to measure. That's why when you describe the distance between two cities, you describe it using the unit miles and not feet. All right, well, let's keep going here. Example 7. It says, how many crates do you need to hold 200 apples if each crate holds 40 apples? So what we've got here is we essentially want to convert a number of apples to crates. So these are our units in this case. So I'm going to start with the 2,000 apples. That's my unit, okay? I'll put this over 1, and we're going to multiply it by conversion factor. Now this one's a little tricky. The conversion factor is right here when it tells you that 1 crate holds 40 apples. What that means is that 1 crate is equal to 40 apples, essentially. Okay? So we need to orient this thing in fractional form such that my apples cancel. So I'm going to put the 40 apples on bottom, and then the 1 crate on top. So now you can see that unit apples will divide out, and we're just going to be left with crates. So I'll go ahead and carry the crate over. 2,000 times 1 is 2,000. Now in the denominator here, 1 times 40 is going to be 40. So we're going to have one last step in which we divide 2,000 by 40. And guys, that's going to give us 50. So 2,000 apples can be held in 50 crates. Now in this particular problem, you can't in a sense say 2,000 apples is equal to 50 crates, because those aren't the same thing. Okay, but we can still use this idea of a conversion factor to figure out how many crates it's going to take to hold 2,000 apples if each crate can hold 40 apples. Okay, so it's the same strategy. All right, well, let's keep going. Okay, probably going to break this up into yet one more video. Okay. All right, so let's keep going. Example 8. It says you want to carpet a room that measures 10 feet by 12 feet, making an area of 120 square feet. Okay, so we don't even have to calculate the area. They give us that automatically, and it comes from multiplying those two dimensions. 10 times 12 is 120 square feet, so this is the unit. Now, unfortunately, carpet is not sold by the square foot, it's sold by the square yard. So we need to figure out how many square yards of carpet we need. So in other words, what we're doing is we're taking 120 square feet, and I can denote that it's square feet by simply using that exponent. Put that over 1. And then we're going to multiply this by a conversion factor, because we want to eliminate those square feet and we want to arrive at square yards. Okay, so how do we do this? Well, you could look up the conversion factor. How many square feet is equal to square yards? Okay, you could look that up. I'll go ahead and tell you what it is. 9 square feet equal 1 square yard. But I want to demonstrate this, why this is the case. So remember a minute ago I said that in 1 yard contained 3 feet. Well, a square yard would look something like this. It would be a square that measures a yard on each side. So this dimension would be a yard, and this dimension would be a yard. But how many feet are in a yard? Well, 3 feet. Okay? So 3 feet in one dimension and 3 feet in another dimension. Now if I find the area of this square yard this way, I'd multiply 3 feet times 3 feet, and that is equal to 9 square feet. Okay? So you could figure it out that way. There are 9 square feet inside 1 square yard. Okay. All right, so that's my conversion factor. Now, how do I want to orient this? Well, I want my square feet to cancel. So I'm going to do it this way. Okay, so that my square feet will divide out. I'm just going to be left with square yards. So 120 times 1 is 120. Go ahead and carry over your units, square yards. And then this is over 9, so we are going to have to divide. 120 divided by 9 is, we're going to get a decimal. And it's a decimal that never terminates. That 3 goes on forever. So in instances like this, lots of times you'll be asked to round. So if I were to round this to the nearest tenth, if you think back to that review video, the tenths place is right here. So there would be a 3 behind it. So that means we round down, or in other words, we keep that 3 at 3. So I'm going to say that this is basically 13.3 square yards. Okay, so we would need that much carpeting to carpet this room. Now in actuality, if anybody has ever laid floors or laid carpet, you know you don't just buy the exact area because there's always waste, right? So you would actually probably want to buy more square yards of carpet. You always want to have some extra. All right. All right. I think I'm going to stop this video right here, and then we'll pick up.